All right, now what I would like you to do first is to do this on the notes page, not the worksheet page, but the notes page with today's date. On your right upper hand corner, could you go ahead and sketch two graphs? Okay, as I said yesterday, I would like you to sketch two graphs. One is the sine graph, the other one is the cosine graph. So y equals to sine x and y equals to cosine x. So take a minute. All right, go ahead and sketch it. Sketch the graph quickly. Again, I said that these two graphs are very similar. And the key thing is, do you know where it starts? So what's sine 0? 0. So that means for the first graph, it starts right here. And what's cosine 0? 1. Okay. So it starts right there. Okay. So so for sine graph, it first goes up or down. It first goes up, and then down, and then up. And then for cosine, it goes down, and then up. Okay, so so that's the graph for sine, that's the graph for cosine. Now make sure you know how to sketch it at any time. At any time. Okay, and always start thinking about where does it start? Okay, does it start at the midpoint or does it start at the highest point? And what we will do today is to go into, of course, more graphing. And the graphs that we'll do, it's going to be a little bit spicier than what we had yesterday, which is good. We're going to see a more variety of graphs today. And we are going to see how things are being transformed. And speaking of transformation, I would like you to write down following two equations at the top of the page. They're not like entirely new stuff. You might have seen this or something similar to this before. So please write down this. Y equals to A sine of B x minus C, close parentheses, plus D. A times sine of B parentheses x minus C, close parentheses, plus D. Does it look familiar? A little bit? Where have you seen before? Algebra 1 or 2. Should have seen this from algebra 2. When we do all those absolute value function, quadratic function, square root function, we have all those transformations, remember? So let's start from the letter D. What is the meaning of the number for D? This letter D means shifting up or down, the vertical shift, which we'll see in a moment. Okay, what about C? Shifting left or right? All right, so that's what C is. All right, let's go ahead and change a little bit. What about A? What's the meaning of A? Stretch, vertical, right, or compression, and also the reflection, right? The vertical reflection. Reflection, what is reflecting across the x-axis. And B, it's for the horizontal stretch. Okay. Now, remember the period for sine and cosine function from yesterday? Period, like the wavelength. So for one complete wave that we sketch over here, What's the period? It's 2 pi. So for today, we will stay with 2 pi. And that means for today, we will go ahead and keep the b value as 1. Tomorrow, we're going to change things up. Okay, but for today, we'll keep the b value as 1. And we'll see all the a and c and d values. So that's the first equation I want you to write down. The other equation I want you to write down is the same equation, but replace the sine with cosine. So technically it's the same thing. It's just a change of function, but the meaning it's exactly the same. The a, b, c, d values. So when you read these graphs, I want you to have a strong impression that this is how you should look at your graphs. Okay, so let's take a look at our first function right there. 2 times sine plus 1, 2 times sine x plus 1. What's the amplitude? In this case, what's the amplitude? Oh, by the way, what is amplitude? From the top to the midline, okay, not the bottom. So if you think that you may forget, go ahead and write this down. And how can we tell the amplitude? How can we tell the distance from the top to the midline? Well, originally for sine x, what's the amplitude for sine x? 1. And there's a 2 sitting right in front of it. That means we're gonna stretch the wave more. So that means the amplitude is gonna be 2. So the way we tell the amplitude is basically looking at the absolute value of A. Just the absolute value of A. So it may be a negative number, but we just look at the number itself. We don't care about the negative. All right, so that's the amplitude. Now, phase shift, it's a synonym for like the left and right shift. Do we have any shifting? Do we have any shift to the left or right? Nope. Any vertical shift? Yes, we have vertical shift up by 1 unit. And now, what about the range? So now, this is how I want you to think about it. Okay, so regularly, for a sine graph, the range is -1 to 1. Okay, again, for a regular sine graph, it's from -1 to 1. And then now it's being stretched by a factor of 2. So that means it's from -2 to 2. And then you move it up by 1 unit. So that means it's now from -1 to 3. Okay. So I do that. That's how I would normally process the information. I would look at the range of the original sine or cosine function, which is from -1 to 1, and then I take all the transformations into account. Any kind of vertical stretch, any kind of vertical shift, and then that's how I end up with the range. Now, there's a way to do this by making a table of values. I strongly discourage that method. I think values are good for checking, but not the primary way of making a graph because it's too draining. It's too much work. I like to relax, chill, enjoy life. Right, so the list of transformations, we have up 1 unit, right? So now, if you give me this, I'm okay with this, okay? Because that gives the meaning, up 1 unit, that's fine. What else? And then we have a vertical stretch by 2. Okay, vertical stretch by 2. All right, so so for the graph, okay, what I said yesterday is that first you've got to know where you plot your first point. So sine function, it starts in the middle. Now I'm going to do this, and I want you to see, okay, how I do it. So first, I'm going to think. Don't put a dot right there yet. I'm going to think that it starts right here, and then it has a stretch by 2. So multiply by 2. Well, 0 times 2 is still 0, and then it's going to move up by 1 unit. I want to make sure that I consider all kinds of transformation, and I think I accounted for all the transformations here. So that's my first point. Any question about where the point is located? If you're okay with the first point, then we use our understanding of period. So I didn't say I want you to write down period right here. The period here is going to be 2 pi. This period will change when there's a b value, but as for now, the b value is 1, so it's going to stay at 2 pi. We'll change up the period tomorrow. So that means after 2 pi, I should expect to see the same point again. Back at the same level after 2 pi. Okay. And the reason why I needed you to sketch the sine graph and cosine graph, because I need you to know the general shape of the graph. I need you to know that this sine graph is going to look like something. It's going to look something like this. Going to go up and down and up like this, up and down and up. So if you have this memory, if you have the idea what the graph will look like, then you know that in between those 2 points, that it will hit the midline again right at the center. And because you know the shape of the graph, you know that between 0 and pi, it's going to hit the highest point. And where's the highest point? Because the amplitude is 2, so it's going to hit 3. And then between pi and 2 pi, it's going to hit the lowest point, which is going to be -1 because the amplitude is 2. All right, so we got 1, 2, 3, 4, 5 points. Any question about the location of these 5 points? How we start right here, and then the second point, it's after one single period, and then we start to use the shape of the graph, symmetry, to develop all the remaining points. Now, if you're okay, then you can go ahead, draw the curve to connect these dots. Again, please use curve, not straight lines. Give your best attempt to draw a curve. Okay? Once you have the first wave, then all you need to do is to replicate it. Replicate the graph. So now there are multiple ways to do this. You can say, all right, I'm just going to repeat the same process again. You could. Or the other way you can think about this is, well, what you can see here, it's every 2 squares. After every 2 squares, you see a major point. So after 2 squares, it hits a major point. After 2 squares to the right, it hits a major point. 2 squares again, major point. Okay? And make sure that the whole graph still preserves the sense of symmetry. If things do look a little bit weird, then it may be showing you something had gone wrong. I think I did something wrong this morning and was like, oh, I could catch myself because the graph doesn't look very symmetrical. Okay. So I hope it's not too hard, not too challenging. Okay. Kind of get you ease into this whole graphing. Okay. Practice. All right, now, if you're okay, I'll let you take a minute or two to finish part B. Okay. Look at part B. Can you write down the range, transformations, all the shifts? Okay, go ahead. Take a minute or two to fill out the information. Okay, so got how many transformations right here? A total of 3. Okay, so first, what's the amplitude? 1. Okay, ooh, that's big. All right, what's the phase shift? To the right, pi over 2. Vertical shift, down 1 unit. All right, so what's the range? So the range for cosine, it's from -1 to 1. Now there's a negative sitting in front of it, so we will expect to see a reflection, but that would not change the range. It's still going to be -1 to 1. So -1 to 1, and then there's a vertical shift down 1 unit. So your new range is -2 to 0. Okay, -2 to 0. So the list of transformations, we have the reflection over the x-axis, shifted to the right for pi over 2 units, and then down by 1 unit. And now let's go ahead and put our first dot. Where is our first dot? Well, originally it should be right here. Originally. But it's been shifted to the right for pi over 2. And then it's been reflected over the over the x-axis. So that means it's now here. Now, cosine was supposed to be at the peak, right? Now, after being reflected, it's no longer at the peak. It's now at the bottom. And then we shifted 1 unit, and we will shift 1 unit down. So this is the lowest point. The period, which is not stated here, let's go ahead and write down the period. The period, it's still 2 pi. So that means 2 pi units away from this first initial dot, we shall see the graph hitting the same level again. So 8 squares away, 2 pi units away to the right, we shall see the green dot at -2 again. And like I said, since it's being reflected, the cosine graph right here at these 2 dots will be at the lowest point. So symmetrically speaking, right in between the 2 lowest points, we shall see the highest point. Between the highest point and the lowest point, we should see the middle point. Okay. Just making sure everything it's symmetrical, 2 squares away, levels are right, range is right, and everything looks good. Took account for all the shifts, reflections, and whatnots. And now we will go ahead and connect the dots. So that would be my first pattern, first wave. Now, how much time does it take? Should it take you to finish the first wave? Now, I would say from the very first moment you look at the equation to the conclusion of the first wave, I would say it should take you about 1 to 2 minutes at most. At most. Okay, it should not take you more than 2 minutes for some moderate level kind of equations. Okay. Now, and I can tell you the remaining tasks that you're gonna learn. The remaining tasks are, well, tomorrow we will change the period, and then, well, guess what? We will give you the graph, and you have to write down the equation. So this is why I want you to be aware of all these A, B, C, D values, how they relate to these shifts, reflections, and the graph shape. And then you would know how to draw the graphs and then also tell the equation of each graph that you see. Okay, so after 2 squares, we will hit the major point. Right there. Okay, so pretty straightforward. Pretty straightforward. Okay, so now let's go ahead, turn to the next page. And I would like you to go ahead and spend the next 5 minutes to finish graph 1 and 2. I hope you can finish these 2 graphs within the next 5 minutes. Should be okay. They're pretty straightforward. If you can finish within the 5 minutes, you can continue to work on question 3 and question 4. So for the first one, what should the range be? From where to where? Top is 1.5, and the bottom part is -2.5. Okay, because the range for cosine it's -1 to 1. You multiply by 2, so it go from -2 to 2, and then the whole thing shifted down slightly by 0.5. So that's why it goes from -2.5 to 1/2. And it's supposed to start at at 1, but because of the multiplication, goes to 2, and then being shifted down by 1/2 units. So that's your first dot, the first point at 1.5. And the period, it's 2 pi. Amplitude is 2. So that means 2 pi units away, it should hit the same level at the peak again. And that means at pi, when x is equal to pi, it should be at the lowest point. At at lowest point it's -2.5, not 1.5, -2.5. Okay, and then And what else? So in between the highest point and the lowest point, it should hit the midpoint, which is the 1/2 line, negative 1/2. So one thing that you should observe right here is that the D value right here, it's always your midline value. Okay, because the midline is 0, right? Y is equal to 0. So if you shift up, then the midline shifts up. If the function shifts down, then the midline shifts down as well. So now I'm going to just draw the first wave, and I'll let you finish the rest of the wave, because I want you to see how you can find out the first wave. Okay. Any question for number 1? How to find the range, how to find the midline, how to account for the shifts. Okay, so number 2, the amplitude is 1/2. Phase shift is right, pi/2. Period, it's still 2 pi for today. What is the range? The range would be from negative 1/2 to positive 1/2. There's no vertical shift. Okay, only a horizontal one. So it's a sine function. It's to start in the middle, but then we see a horizontal shift to the right for pi/2. So my first point would shift to the right for pi/2 units. And then we will start our first point right there at pi/2, 0. And then because the period it's 2 pi, so we will go 2 pi units to the right to 5 pi/2. That would be my second point right here. And since it's a sine function, it should go up and then hit the midpoint again, and then it goes down. So that means somewhere in between those 2 points, we should see the midpoint again. And because the amplitude is 1/2, so it will go up to 1/2, back down to 0, down to negative 1/2, and back up to 0. And that would be your first pattern, your first wave that you would draw, and then you would replicate it left and right. Okay? So I'll let you replicate it. I'm not sure about you, but for me, I find this graphing activity very soothing, very relaxing. Just find out the first point, look at the period, just look for symmetry. It's not too challenging. Okay. All right, take the next couple minutes to work on number 3 and number 4. Okay, you can use these 2 as an example. So work on number 3 and number 4. All right, let's take a look at number 3. So for number 3, what's the amplitude? Amplitude is 2. And amplitude is 2. And the whole graph is shifted up 1 unit. And then shifted to the right for pi units. Period, it's still 2 pi. What's the range? So the range was negative 1 to 1. Amplitude is 2, so from -2 to 2. And the whole graph is being shifted up 1 unit. And -1 to 3. Okay. I don't mind you doing this during the quiz or test, as long as you can visualize it. Okay, I like to visualize my my floor and ceiling, and seeing it how it would change up and down before I make my conclusion. Now, so what's my first point? My first point is right here, originally, but then it's being shifted to the right pi units, and then up 1 unit. And I also need to consider that this is a negative sine function. Yes. Well, the two, it's, well, we care about the negative because it's the reflection, but the reflection does not alter the range. So that's why we didn't talk about the minus as we discussed the range. All right, so so that's my first point, and here it's 2 pi, so that means 2 pi units away. We'll see the same point again. Now there's a minus in front of sine. That means it's being reflected. So if you look at your original sketch, sine function goes up and then down, right? Because it's being reflected, so now the sine function is going to go down and then heading back up. So it would go all the way down 2 units to -1, and then back to 0, and then up 2 units to 3. And by the way, when you do all these graphing, you will find out that the information has to be aligned, or they have to match. If you do some incorrect shifting, then your amplitude may be wrong, or the graph may look tilted or awkward, and that's how you know something something it's done improperly. So that's my first wave, and then you can go ahead and replicate the rest. Okay, so again, your first point, it's extremely crucial. Spend a lot of time to make sure that your first point is correct. And once you get the first point correctly, you may proceed. And by the way, if you want to make sure that your first point is correct, just put the x value back in here, back into the x, and check it for yourself. Okay. And for question number 4, number 4, it's what is it called? It's a cosine function. The amplitude is 1, but it's being shifted, and then it's being shifted to the right pi units again. Period, it's still 2 pi, and the range in this case, what's the range? The range is 1, 2, 3. At first, I was worried that how part of the graph is being cut off. I was like, oh, that's the reason why it's being cut off, because we're only using the top half of the graph. So originally, this is a cosine function. We will start at 1, but then it's being shifted to the right by pi units, and then it's being reflected down, and then it's going to be shifted up 2 units. So back at this point. Okay. However, this is a reflected cosine function. So that means this is the lowest point. So 2 pi units away, we see the lowest point again. In between the 2 lowest points, we see the highest point. Okay, so that's your first pattern, your first wave, and then you will go ahead and replicate the remaining part of the graph. Very good. Okay. So make sure you can draw, redraw, try it out multiple times. Again, 1 to 2 minutes, that's all you have.